Resume. What's up, interweb? Okay, we're
More.
gonna morning. We're gonna finish our. You believe it's the last class period? My goodness, did this semester go by fast? Hate to say I told you so, but I told you so. Okay, and remember the final exam. I'll mail it. I'll email it to you. WILL. I'm probably going to do it on Monday night or Monday after. Excuse me, Monday afternoon after my nap. Be emailed to you. Um, you must finish by 12 noon. Capital T. Tuesday. I think that is the 12th. Okay. Must be finished. You can email me back the grades. I'm sorry, the grades. Your answers, or you can just put them on a return email. You know, number one is A, number two is B, number three, like that. Or I'll send you an answer sheet and you can use that and you can either take a picture of it and send it to me or email it to me as an attachment or whatever's easiest for you. Okay, number 17. Excuse me. Number 17, I think that's where we left off. It's cold in here. Hate to be a hater. I hate on the cold. Let's see if I can straighten this up a little bit. Okay. Simplify. Now remember, the one thing about parentheses is it makes everything in here one number. Now there's no pluses or minuses in between the terms. So this is one term, and this is one term. So there's no distributive property or any of that because they're both just one terms. So take them one at a time. It's really very simple. Do I say that a lot? Yeah. Okay, so we take -4 times 2 is -8, I think. X to the 6 times x to the -1. Now remember, when we have same base numbers and we're multiplying, because there's nothing in between here, this means to multiply this number times this number. So it's going to be, so what do we do with the exponents? We add them. Let's see, 6 minus 1 is carry the 7, 30 days of September to the 5th. Okay, 6 minus 1. And then y to the 7th times y is y to the -6th. Now remember, the instructions will say all positive exponents. Remember, this is actually over 1. We just don't write it because we're lazy. Now remember, if the exponents are positive, leave them where they are. Now the -8 has an exponent of 1. Again, we just don't write it. So it's -8. X to the 5th is already positive. And x to the, I'm sorry, y to the -6 goes to the bottom and becomes positive. Okay, number 18. Number 18 is super simple, 3 over 10x squared. I think the instruction said to evaluate this if x equals -6. Okay. Now, all we do is we put -6 in for x, and that's 3 over 10 times x is -6 squared. Now, this is nothing more than order of operation. Very, very simple. That's 3. Now, do we have any parentheses? Yes, but there's nothing to do in here. Do we have an exponent? Yes, we do. This means to multiply the base number times itself twice. So it's going to be 10 times, what is it, 36? So this equals 3 over 360. 10 times 36 is 360. Now we can reduce this by 3. That's 1 over 120. $19. Everybody okay? Am I going too fast? Please tell me if I'm going too fast. Kotran, komenyotham. Kotran. I bet you she's out smoking a joint. What do you want to bet? Mm-hmm. Okay, number 19. We really didn't do this very much, if at all. 8y to the 4th plus 8y cubed minus 9. Now they're asking you to find the degree of the term, and like that. And what kind of number is this? This is a trinomial. Because there's 3 terms. Tri meaning 3, nomial means numbers. And the degree, I don't think we did this. The degree is the sum of the exponents. So the degree is, oh no, they're asking you for something. Let me see, what are they asking you for? I'm sorry, number 19. Find the degree of the following polynomial, determine whether it's a monomial, blah, blah, blah. Okay, 19 is A. Okay. Okay, the degree is the largest exponent. So in this case, it's a trinomial, 3 numbers, and the degree is 4, largest exponent. Number 20. Now you're going to look at this and you're going to think, oh my God, I can't do this. It's super simple. 7x cubed, open. 7x cubed plus x to the 5th plus 1 minus 6x to the 4th. Don't get all wild here. This is real easy. Minus, open, 5 minus 9x to the 4th plus 3x to the 5th minus 4x cubed. Now, there's kind of order of operation here. The first thing we do is we're going to distribute this negative. This is actually -1 times everything in here. Now, all that does, it doesn't change any of the numbers. It just changes the signs of the numbers. So we have 7x cubed plus 9x to the 5th plus 1 minus 6x to the 4th. Nothing changed in here. However, these over here are the only thing that's going to happen is we have to distribute the -1 times everything in here. And effectively what happens here is the signs change. So it's going to be -5th plus 9x to the 4th, because a negative times a negative is a positive, minus 3x to the 5th plus 4x cubed. Now it's nothing more here than combining like terms. Real simple. X to the cube, x to the cube, x to the 5th, and x to the 5th. And 1, -5, and then x to the 4th, x to the 4th. Is that everything? I think so. Okay. Let's take 7x cubed and 4x cubed. 7 and 4 is 11. So we have 11x cubes. Now I cross these out so I don't get confused because I'm stupid. Now x to the 5th, here and here. This is nothing more than 9 minus 3. So this is plus 6x to the 5th. Okay. 1 minus 5 is -4. And x to the 4th here and here. This is 9 minus 6, which is 3. X to the 4th. Is that right? And there's nothing left. Okay, now we want to put these in order, largest exponent first. So it's going to be 6x to the 5th plus 3x to the 4th plus 11x cubed. There's no squares. Was it -4? And that's our answer. Remember, largest exponent first. If the exponents are the same, alphabetical order. Okay, 21. Okay. Take a drink of your Diet Coke. Okay, again, a really very simple problem. All we do is distribute the -y times everything inside the parenthesis. . And remember, when we're multiplying and we have the same base number, we add the exponents. So we don't have the same base number here, but we do have a negative 6x cubed y. Okay, y times 6x cubed is, remember, it's negative y. And then plus 4y squared. Okay, negative times a negative is a positive. 4y squared. And then negative y times 3x is, again, a negative times a positive is a negative xy. And then we have negative y times negative 8y cubed is a positive, negative times a negative, 8y to the fourth. Right? Right. Now, if we were to do this properly, we would have the 8y to the fourth, and then this one, well, probably this one, and then that one. But like that. 22. 22, we have distributive property. You know, these were the real simple ones. I don't know why they don't put these at the beginning of the test. Mm-hmm. Okay. These are, can y'all see that okay? Okay. This is distributive property. There's no plus or minus in here, so this means to multiply. 2x times everything over here. 2x times 3x is, was it 6x squared? And 2x times a negative 8 is a negative 16x. Okay, now that takes care of the 2x. Now we do the same thing with the 11. We multiply it times everything over here. Plus 33x minus 88. Okay, middle two terms are typically common. So we have 6x squared. 33x is minus 16, I think is 17. Positive. Look, at this point in the test, your brain's going to go numb. You're going to lose focus. So don't hesitate to use your calculator here to do this. Minus 88. Mm-hmm. 23 is basically the same problem. It just looks different. Okay. Where are we? 23? Okay. 7x plus 4. All squared. Now remember, the parentheses makes this one number. So it's this number, as we say in North Katy, times its own self. Yeah, we say that. So it's 7x plus 4 times its own self. Right? Right. Distributive property, super duper whiz bang important, and thankfully very, very easy. Okay, so we do 7x times everything over here. And that's, where's that, 49? X squared plus 28x. Okay. Wait a minute, what have I done here? Yeah, that's right. Plus, now we do the same thing with the 4. We multiply it times everything over here. plus 28x plus 16. Again, middle two terms are typically common. So this equals 49x squared plus 56x plus 16. Right? 24. Okay, 24 we did not do. I'm sorry, we just didn't have the time for it. And it's stupid anyway. So the answer to number 24 is C, I think. Okay. Okay. So what do we have here? Factorage. They want you to factor all this misery. So if we have, get this one if you're so doggone smart. 49x squared plus 64. Now what do we have here? Is this a conjugate? No. Because a conjugate is the difference of two squares. Now everything in here is a square. The square root of this is 7x. Square root of this is 8. But it's the sum of. So this is prime. Okay, you cannot factor that. 26. Okay. 25 x squared. Did I hit the record button? Yes. Oh, what a smart boy Johnny is. Minus 121y squared. So do we have a conjugate here? Yes. This is a perfect square, and this is a perfect square. So this equals, okay, so what's the square root of all this? Is 5x. And the square root of this one is 11y. Okay, so these two things are the same. These two terms are the same, except one's positive and the other one's negative. Stupid boy, this is 11y. Let me rewrite it. 5x plus 11y times 5x minus 11y. Okay, the difference of two perfect squares. 27. Y'all excuse me for just a second. Okay, I'm sorry. Number 27. 512 x cubed minus 343. Now, what do we have here? We have the difference of ERENCE of two cubes. Difference of cubes. If you have a calculator, you should have somewhere on there. If you've got this, the little one here, first you turn it on. If you look up here above the little caret, it has x right there. So what you do is you put in, so if we want to know what the cube root of 512 is, we hit, now you see that's in orange. So we hit the fifth key, that's orange. Cube, well, why don't you be more stupid? Fifth key, no. We want the cube. Well, it's stupid. Turn it on. Three. Okay, we want the cube root. So 3, and then hit this thing of 512 is 8. Okay, so this is 8. This is x cubed. Now 343, again, you hit 3, then the cube root where it says x and the square root symbol of 343 is 7. Right? Right. Okay, so you put we want this and then this symbol, because it tells you the cube root of this, and then the 512 and it equals 8. Okay, so our x, remember the formula for this is x minus y times x squared plus xy plus y squared. Okay, so our x here is, remember this is going to be our x, and this is going to be our y. So if x cubed is 512 cubed, 512 x cubed, right? And y cubed is 343. Then what is x? X is 8. Take the cube root of each one of these. So our x is 8x, and our y is 7. I think you'll find this is the easiest way of doing this. Now all we do is we plug in the numbers. It's actually very simple. So x is, okay, so again, I'm going to rewrite this. X minus y, x squared plus xy plus y squared plus, okay, so x minus y, so it's 8x minus 7 in parentheses. Now x squared, if x is this, then x squared is 64 x squared, right? Right. Now we have plus xy plus, where's our x? xy. So this is, don't forget you have to multiply these two things. So you get 56, 56x. Okay, we multiply these two things to get this, plus y squared. Y squared, y is 7, so y squared is 49. I made this sound more complicated than it really is. It's actually pretty simple. Can y'all see this okay? Ms. Garcia, are you there? You out smoking? I knew it.
I'm here.
You are. Can you see this okay? This paper?
Yes.
Okay. Because on my screen it's real small. Okay. Oh, what a bump. Oh, I did do that. Okay. All right. Where are we? 28? Okay. 28. Again, this is factoring. 7x squared plus 40x plus 25. Now remember, when the coefficient of the quadratic term makes up this stupid stuff, this number, when this number is not 1, we have to multiply. Remember, this is ax squared, and this is bx, and this is c equals 0. Okay, we have to multiply a times c. Now, a times c is 7 times 25, which is 175. Now we want the factors of 175 that add up to 40. Okay, and I'll tell you, you really only have to go to 5. Let's see, 8 and 5 is 13. So, yeah, there's really only one factor that you have. 1 will go in there, of course. 2 will not. 3 will not. 4 will not. But 5 will. 5 times 35. And there's our factors. Now, remember, what we're wanting to do is split this term up. This is called the linear term. We're going to split that up into 2 terms. 7x squared. Now we're going to put the 35 next to the 7. Plus 35x. Now we're going to put the 5 next to the 25 because they're factors of each other. Plus 5x plus 25 equals 0. Okay? Now we're going to group these together. We're doing groupage. Now, what can we factor out of this term here? 7x. There's a 7 will go into both of these, and x. Don't forget there's an x in each one of these. So that times x plus 5. Now I do these backwards because I'm stupid. 7x times x is 7x squared. 7x times 5 is 35x. That's right. And what can we factor out of both of these? 5. Equals 0. Okay, now remember, these have to be the same. If they are not, something's gone wrong. So we have 7x plus 5, okay, this and this, times x plus 5 equals 0. Okay? Only 11 more. I think I'll never see y'all again, ever. Everybody says, oh, yeah, we'll come back by and say hello. Nobody ever does. And I cry and cry. Okay? Now we have this. Same stupid problem. The only thing is there's another variable in here that we have to deal with. So the first thing we do is a times c. So this is 9 times negative 35 is negative 315. And I will tell you, well, let's see, 4 and 5 is 9. 3 will go into here evenly. 5 will go in there evenly, of course. I'll tell you what the factors of this are, and that is 21 times negative 15. So what are we going to do here? We're going to put the, let's see. Okay, and again, we're going to split this term up. And this is actually y here. 9x squared. Let's see, which one do we want to put here? 21, I guess. Plus 21y. 21. Stupid boy. xy. Okay, because we're splitting this term up into these two. 21xy minus 15xy. Okay. This is the same thing as this. Minus 35y squared. Now we group them together here and here. There's a plus in here. Okay, so what can we factor out of here? What's in both of these terms? 3 and x. Right? Now, what can we factor out of here? Negative 5. Negative 5y, because there's a y in each one of these terms. And what is that going to be? 3 and the x. We factored out the y. 3x plus, okay, negative times a negative is a positive. Plus 5 will go into 35 7 times, and there's one y left over. Okay, I'll do it backwards. It only takes a second. 3x and 3x, 9x squared. 21xy, yep. Negative 5y times 3x is negative 15xy. Yes. Negative 5y, negative 35y squared. That's right. So we do this one and this one. Oh, and these two terms were the same, so we're correct. And then where are we? 3x plus 7y. And remember, we have two of these terms, but we only use one of them. What fun is this? Okay. Okay. Basically the same problem. We're just doing groupage here. Number 30. 5xy minus 25 x closed plus 6y minus 30. Okay, so what can we factor out of this first one? This is actually easier than the problems before it. This is nothing more than grouping the terms together. Oh, that's a good Diet Coke. Hey, what can we factor out of both of these? 5. What about these? X. There's an x in here and an x over here. 5x times What is it, just 1? Minus 5. Is that right? I think so. 5x times y is 5xy. That's right. And 5x times negative 5 is negative 25x. That's right. Now what can we factor out of here? 6. Y minus 5. Again, these two terms are the same. So our factors here are 5x plus 6. Okay. 5x, 6, and y minus 5. Right? Right. Okay. Mm-hmm. Okay. Now these 31, 32, 33, they want you to evaluate. Evaluate for x. In other words, how much is x? So the first thing we have to do is we have to factor, set them, first we set them equal to 0. So if you have x squared minus 3x equals 0, now we have to factor this. What can we factor out of both of these terms here? X. So we have x open, x minus 3 equals 0. Now we have two terms here. Actually, there's one term, but there's two parts of it. So we set each one of the factors equal to 0. So we say that x equals 0. Well, that would solve for us already. And we do x minus 3 equals 0. Add 3, add 3. So x is equal to 3. So our answer here is 0, comma 3. These are the two. And if you have a graphing calculator, you can put this in your handy dandy graphing calculator, and it'll come out looking like this. It'll come out, be a parabola, crosses at 0 and at 3. 0 and 3. Oh, I'm sorry, that was number 31? I think so. 32. Take a drink of your Diet Coke. Mm-hmm. Okay. So we have this. If we have 3x minus 54. So we have 54. What are the factors of negative 54 that add up to 3? It's 9 times negative 6. Okay. So we have we can split these up into negative 6x and 9x. Okay, we get x squared minus 54 equals 0. So we have this. Okay, we're going to group these together, group these together. Now what can we factor out of here? Just an x, right? We get x minus 6. And what can we factor out of here? Looks like a 9. Yeah, 9. Okay, these two terms are the same. So we have x plus 9 and x minus 6 equals 0. Okay, so we set each one of them equal to 0. X plus 9 equals 0. Therefore, x is equal to negative 9. We subtract 9 from each side. And we have x minus 6 equals 0. So x is equal to 6. So we have negative 9 and 6. Okay. 33 is 9x squared minus 11 equals 30x. Now remember, on these, the first thing you do is you set it equal to 0. So we have to subtract 30x from each side. 30x. And we get 9x squared minus 30x minus 11 equals 0. Now we do a times c is 9 times negative 11, which is a negative 99. Now, what are the factors of negative 99 that add up to negative 30? So negative 33 times 3. Mm-hmm. I'm going to split the linear term up into these two terms, 3x and negative 33x minus 11 equals 0. Now we group these together. Remember, there's a plus in here. So what can we factor out of this? 3x times 3x plus 1. 3x times 3x is 9x squared. That's right. 3x times 1 is 3x. That's right. Now, what can we factor out of both of these terms? Negative 11. Right? 11 will go into each of these evenly. And we want the negative out here so we can have this term in here to be the same. So we have 3x minus 11 times 3x plus 1 equals 0. Okay, now we set each one of these terms equal to 0. 3x minus 11 equals 0. Add 11. Divide by 3. Then x is going to be equal to 11 over 3. I don't know why, but these people love fractions. Then we have 3x plus, okay, that's this one. Now this one, same stupid thing, 3x plus 1. Set each one of these terms equal to 0. Subtract 1, subtract 1. So 3x equals negative 1. Divide by 3. And x equals negative 1/3. So there's our answer. Our answers. Negative 1/3 and 11/3. Mm-hmm. What happened to number 34? And 33. Huh. Let me see what 34 is. Okay. Okay. Sorry. Sorry. Mm-hmm. Okay. Okay. What if we have 34 is 9x cubed minus x equals 0? Do we have the difference of cubes? No. So what can we factor out of each one of these terms here? X times 9x squared minus 1 equals 0. Now what is this? I hate to say I told you so, but I told you so. Look for conjugates, and this is a conjugate. It's the difference of two perfect squares. So we have x times 3x plus 1 times 3x minus 1 equals 0. Remember, this is a perfect square. Each one of those is a perfect square. So we take the square root of each one of them. Now we set each one of them equal to 0. X equals 0. That's one answer. Then 3x plus 1 equals 0. And 3x minus 1 equals 0. Here we subtract 1 from each side. 3x equals negative 1. So x is negative 1/3. This one we add 1 to each side. 3x equals 1 divided by 3. X equals 1/3. I'm sorry I went real fast there. I'm sorry, but it's really very, very simple. Okay, so factor out an x first, and you have a conjugate, and then we set each one of them equal to 0, and then you have very simple algebra problems. Mm-hmm, mm-hmm, mm-hmm. Okay. 35. 35, they want you to solve by graphing. Now, remember, this is y equals mx plus b. So on this one, our slope is 1, right? There's a 1x right here. And the and the y-intercept is 4. Okay, so it's going to cross the y-axis at 4. 1, 2, 3, 4, and has a slope of 1. Now, a slope of 1 means up 1 over 1, up 1 over 1. Use the bigger. Anyway, or it could be down 1 and to the left 1 also, down and to the left. Okay, so this is going to look like that. And the second one is y equals 2x plus 3. Okay, now here our slope is 2, okay, mx plus b, and our y-intercept is 3. So our y-intercept is 1, 2, 3, and our slope is 2. Okay, now slope, remember, is rise over run. In other words, how much does it go up or down? How much does it go side to side? Our slope is 2, which is actually 2 over 1. It goes up 2 and to the right 1. So it crosses the y-axis at 3, goes up 2 and over 1. There's our intercept right there. Okay, and this is going to look kind of like that. So our intercept, or our solution to these two equations is, what is it, 1, 5? 1, 1, 2, 3, 4, 5. 1 comma 5 in parentheses. That makes it a point. Okay. Now remember, on these things, there's 3 possibilities. There's one solution. Now, if you have the same slope and different y-intercepts, like this, if you have the same slope, different y-intercept, these are parallel. A-R-A-L-L-E-L. And there are no solutions. No solution, because they don't cross. Now, if you have the same slope, SA, let me write this over here. If you have the same slope and the same SAME y-intercept, what do we have? Same slope, same y-intercept. We have the same line, one right on top of the other one. So how many solutions are there? An infinite number. Because each point along the line is will be common to both lines. And that's oh, there was 34 over there. Stupid boy. And 36. Hold on just a second. 36. Okay, what you need to know for number 36 is this. If you have the same slope and same y-intercept, you have an infinite number of the same lines. Infinite number of solutions. 36. Yes. 37. Okay, it says to solve this by any means. 2x minus 7y equals 32. 7x plus 4y equals negative 2. Now, system of equations. Now, what you want to do here is, it'd be too hard to, you can do it, solve for one variable or the other. But then if you do that and then substitute it into the other one, you're gonna have a real difficult time here because you're gonna end up with fractions and all that misery. So what we want to do is eliminate one of these, one variable or the other. So let's get rid of these here. So we're going to multiply this by 7 and this by negative 2. Because 7 times 2 is 14. Negative 2 times 7 is negative 14. That'll eliminate these two. So we're going to end up with, we multiply 7 times everything in here. That's 14x minus 49y equals 224. Now we multiply negative 2 times everything here, and we get negative 14x, and that's what we want. We're going to eliminate this. Negative 2 times, that's 14. Negative 2 times 4 is negative 4 equals 4. Now remember, this bunch of equations and this are the same. They just look different. Now we're going to add these together. 14x minus 14x is 0. It's gone. It's eliminated. Now we end up with this. That's negative 57, I think. Y equals 228. Okay, so we divide by negative 57, and y equals, remember the fraction bar means divided by, so 228 divided by negative 57 is 4, negative 4. Okay, now we can plug in negative 4 into any of these equations. Let's use the top one because the numbers are smaller, and I'm a lazy boy. So we have 2x minus 7 times negative 4. Okay, we're just substituting the negative 4 in for y up here. Equals 32. So we have 2x plus 28 equals 32. Okay, now we have real simple algebra. Subtract 28 from each side. And we get 2x equals, was it 4? Divided by 2. X is 2. Okay, so where do these cross? At 2 comma negative 4. Remember, this is a point, so it's to be written like a point in parentheses like this. X and Y. Right? Right. Okay. the world is this? I think this is one of those problems where the first number is this and the second number is that. Let me see. I don't think, if we did this, it was real early in the year. Yeah. Okay. Okay. 38. The first number is 4 more than the second number. Two times the first number is 4 more than MO. Don't you love these? I'd love to find the godless Yankee that came up with these. Strangle them. Or more than 4 times the second number. Okay? Look, these are actually pretty simple. It's just that they're written in words. So what we have to do is convert the words into numbers. Okay, first of all, we're going to say the first number, we're going to call F for first. The second number, we're going to call N. I don't use S's because my handwriting's so bad. Okay? So look, take this real slow and write it in numbers. The first number is, how do you say the first number? F. How do you say is in math? Equals 4 more than the second number. Okay? That's our first one. Now, everybody get that okay? Now, just take these slow, and like I said, write it in numbers. 2 times the first number. So 2 times the first number is, again, that's equals 4 more than 4 more than, where am I? It's 4 more than 4 times the second number. So 4 times the second number is 4n plus 4, because it's 4 more. There's an awful lot of 4s in this thing. I'm sorry. Y'all excuse me for just a... Okay, so we have a system of equations. Now the simplest thing to do here is substitution. We already know what F is. F is this, equals the same. So we just substitute it into the other one. So 2 times n plus 4 equals 4n plus 4. The most difficult thing is this misery here. But just take it real slow, and it'll work out pretty well. Okay, so now on a problem like this, it's real easy to get bogged down here and know what the hell's going on. So just do what you can do. what can you do here? You can multiply 2 times everything in here, that's distributed property. So we get 2n más 8 equals 4n plus 4. Okay, remember, move the variables first. It doesn't really make any difference, but it'll make it easier. And move the smallest number to the biggest number. So let's subtract 2n from each side. Not x, you bonehead, is n. So this is gone. We have 8 equals 2n plus 4. Is that right? Yeah. Now we subtract 4 from each side. 4, boy, there are more 4's in this thing. 2n divided by 2. So n is, that's the second number, 2. Now how do we find the first number? Simple. We just plug it back into this first one because it's already solved for f, the first number. Our first number is n plus 4. So 2 plus 4. So our first number is 6. Right? Right. Okay, 39. Where is... Okay. Okay. 39 is solve the problem. And if a store has a sale of 25% off everything, find the discount. If a ring, I don't know, a CD player is $1,200, that's some CD player, huh? Now look, all they want is the discount. They don't want to know what the end, how much it ends up costing you. They just want to know what is the discount. Now look, you cannot use percent in calculation. You have to change this to a decimal. Now the decimal point is here. We just don't write it. So we always move it 2 times to the left to get the decimal equivalent. And that's 0.25 times 1,200. I think that is, what's it, 300? Something like that. So 0.25 times, is that right? Yeah, 300. Okay. Remember, the only thing you need to be aware of here is you have to move the decimal point. You cannot take 25 times that. It's 0.25. You have to move the decimal point in order to get that. Okay, I'm not sure whether we did these or this next one or not. Number 40, last one. A commercial says that 2 out of every 9, let's say 2 out of every 5 doctors, OCTO, recommend a certain medication. If a hospital HEITAL has 300 doctors, how many would you expect? How many would recommend MEND this medication? Okay, this is a very simple proportion. 2 out of 5. 2 out of 5. Okay, part over whole equals how many doctors, 2 doctors, recommend. How many doctors, we don't know. If the total amount of doctors is 300. Okay, it's real simple. We cross multiply. 5 times x is 5x. 2 times 300 is 600. Very simple algebra. Divide by 5. X is 120. 120. Okay? Now, does it make sense? Is it reasonable? 2 out of every 5, that's 2.5 times. 2.5 times 120, is that 300? Yes. So we're probably right. Does anybody have any questions? Anything you want me to go back over? Everybody okay? Well, it's been good knowing y'all. Remember, I'll email you the final probably Monday, and I want them back by Tuesday, no later than 12 noon. Otherwise, you get a 0, and you have to do all this stupid course over again. Okay? All right, y'all have a good weekend and a good life. And get out there and get jobs and pay your Social Security so I can retire again. Okay.
All right, you have a good one.
Thank you. You too. Bye-bye.
Happy day.
Bye-bye. Thank you.